Now, since this is heat pump, it has different modes. So we have already explained the heating cycle. It moves the heat from outside to the inside, but it also can do, that also means it can do reverse cycle. We are cooling down the internal space and then rejecting the heat to the outdoor space. So in the two mode, everything is the same, but it's the fluid inside the pipe is moving opposite direction. Okay. Most of us probably have seen some of the cases like systems like this in very hotel. There is a packaged terminal. It can be packaged terminal heat pump or packaged air conditioner. In some modern houses, residential apartments, we see a lot of like mini split system. It can be heat pump or air conditioners. So why do I put the heat pump and the air conditioners in here? Because they are operating the same way. The only difference is the heat pump can operate under both heating and cooling mode, as I explained previously. But the air conditioner it only operates for the cooling mode. For the heating side, it is using the electricity directly to heat up the coil. Okay, so these two cases is basically there's no water plant involved inside. It's all from outdoor air to indoor air. And this is a diagram from an EnergyPlus input and output reference. We can see we can use a unitary heat pump system to build up an air loop. There is a fan and a direct expansion cooling coil and the heating coil and the supplemental heating coil. So why do we need that? So in some cases, the heating coil is not generating enough heat for the system for the room, and we usually will have additional electric heating coil to back up the DX heating coil. So this is one example, and another one is a ground source heat pump. So in this case, we have a water loop and the air loop, which is the load side of the entire system. And we connect both the heating and cooling coil inside this source water loop. We just replace those heating coil and cooling coil on the air loop side and rejecting or absorbing the heat from the ground. So this you are using the ground as a heat sink. So this is a very briefly introduction for the heat pump. If you want to know more about the systems, including other like the chiller or cooling tower or boiler heat pump and or any of the systems, because there are a ton of tutorials out there that can help you to learn more about the mechanical system. So one is engineering mindset and MEP Academy, MEP engineering tutorials. These are links you can go and search for their tutorials. Now let's go back to the grasshopper to see how do we model those systems. Okay, now let's disable this one first. Now we have one heat pump system that generates the hot water for the baseboard. But since we can also use this heat pump to generate chill water as well, can we use this system to adjust the cooling load as well? How can we do that? So for the hot water loop, probably we can change the supply temperature to 84. Because in the reality, probably the most of the heat pump can only generate the temperature for the hot water around 54 Celsius, and the rest is matching with this template. You can delete this guy, and let's try to combine these two systems together. Okay. So, okay. output parameter. We just remove this guy, remove this guy. This is the heating side. And chill water. So this is chill water, this is hot water loop. And we have two loops. Alright. So now we have two loops. One for chill water, one for hot water. But on the zone equipment side, we only have the baseboard, which only uses hot water. What can we do for chill water? We can probably use reading panel, which can be used for both heating and cooling. For the reading panel, we can also use a template from the advanced system number 13 reading ceiling with electric OS. Okay, delete this one. So there are several steps to set up the reading ceiling system. So one is we have to set up the construction to ensure where we want to place those internal source, where those reading those pipes go through. Here is the internal source, which means where those water pipe goes through inside the construction. And we just update the construction of each room. And here is the system. Let's double click the cluster. We can see here we can just ignore the OS system for now. So zone reading panels, we can just copy this area, Control C. And also we can briefly look at the existing hot water and the chill water loop. So here it's using boiler to generate hot water, and then it's using the chiller to generate the chill water. But we already have the heat pump to generate both hot water and chill water. So all we need to do is just copy the zone reading panels, Control C, and close, no, and Control V. So this is where we can set up the zone equipment. Okay, we don't need this air terminal. So zone equipment, we have this one already. So this is the reading panel. We just delete everything, delete to the baseboard, and connect to the zone equipment to the reading panel system. Let me move that around. So this is a heat pump system. Heat pump. Okay. All right. Now let's just connect all rooms to this input. It automatically duplicates a heating coil and a cooling coil to generate 8 reading system for each of the rooms. Okay. Now and you can see it's not connected to the water loop as well. So we can just grab this cooling coil to the hot water's this demand side. So it's generating the hot water and pumping into this breathing panel. And the same thing goes to the cooling coil. Connect to the demand side. Okay. And now we have everything connected. We can probably try to run the simulation. Before that, let's Control S, save the simulation, save the file, and then run. So we got an error. Let's look at the error. So chill water loop demand branch missing required property. Okay, something related to the chill water branch demand branch. Oh, because let's say we have eight cooling coils, but here says it's one branches, which is not correct. All we wanna have is one chill water loop, but we need 8 branches for each cooling coil. So we can use tree graph G component, and then to make the so beginning there are A values inside the list. Now we change the data structure to 8 branches, and each branch has one component or one coil inside. So once we do this, it becomes 8 branches. Let's check the cooling, the heating side. Heating side, we need to do that as well. Okay, copy paste. So the heating coil and branches, and Control S, save, run. It's getting the error again, but different error. Demand missing. Okay. So this is a chiller. That's fine. I think it is. We have everything connected correctly. And oh, we forgot to change the construction set. So let's just copy this one. We don't need this guy because we have a system set already. So let's use the same thing to set our constructions. And move everything to the right. So we have enough space to add the constructions. Okay. So connect here. Disabled. Just make a copy. Flatten the data. This is the blue. Okay. So here we just set up to the construction set for the reading panel, reading ceiling, and now we have the system set correctly. And clean up a little bit. And then apply the system to each room. And Control S and save it again and run again. Something wrong with the show what looked inside. What's the issue there? It looks all fine to me. So the next thing, I guess we can just open the Open Studio. Plus we can set the run to 2. So basically translate the model to Open Studio model without running it. Let's see if this will help us to debug the model. Copy. Let's go to the HVAC tab and show what loop. It should be fine. Let's check the zone. Each zone seems fine. Ceiling. Let's check the consumption if it's set correctly. Basis. The ceiling. So it seems the construction is not set correctly. Okay, let's go back to the script. Oh, because I set extraction after this, and then I assign system to the room before the construction. Yeah, so this is the reason. All right. So all we can do, let me disable this one, and this is a room with reading system, and then replace this one. Okay, so this is a room with the construction set correctly, and then apply the system, so everything should be fine now. It seems it didn't run. Oh, it's because I set the run to 2, which only translates the model, doesn't run the model. Okay, now it seems running fine. Alright, now let's Control S, save the file. We can see one of the biggest change is the heat pump, total heat pump, the energy used inside the heat pump. It was around 2 or 3, now it's 18. The total becomes 89. And I guess we can also check the ambient hour first. Alright, so it seems all fine with the ambient hour for the heating, but seems the cooling side it doesn't adjust. Yeah. So all rooms still having the cooling issue. So that means probably, let me see what's the issue here. So it might be because the temperature schedule here for the cooling system, the temperature here is 24 for the cooling to turn on is a bit too high. We can see if we can change to 23. Cancel that first. Let's check the cooling set point and change this one to 23. 24 might be already a little bit higher than the cooling set point. So this is let's try to get the each room's cooling set point. This is the room property, and maybe let's see cooling set point. Value. So cooling set point it was set to 24, and we were using the 24 to turn as a temperature to turn on the cooling system. So it might be too close to each other. So let's see if this one helps. To 23. Let's run again. So we can see the total EOI is getting even higher because we are turning the cooling system at even lower temperature. So basically we are trying to maintain the indoor temperature at a lower value. So that's why it uses more energy. And let's check again. So it's the same thing, I believe. The cooling, hour still doesn't work. So I guess we can definitely look into this system more in detail. But I think the reading panel for the cooling doesn't work for this case, or doesn't cool the room enough for the space. So let's see if we can find another alternative. So the reading system for the cooling won't work, so we can try to use the air force system